Black holes are mysterious objects in space with gravity so strong that nothing can escape from them, not even light. Because they don't give off visible light, they look completely black and seem to vanish into the background of stars. They were first predicted in 1916 by Albert Einstein through his theory of general relativity. Back then, black holes were only an idea without any real proof or observation. It wasn't until the 20th century that technology became advanced enough to help scientists find black holes indirectly. In the 1960s, astronomers found a bright blue star in a system called Cygnus. This star was moving in a way that showed it was orbiting an invisible object. That object was pulling on the star with a strong force, even though it couldn't be seen. Later, this unseen object was confirmed to be Cygnus X1, a stellar mass black hole. It became the first solid evidence that black holes truly exist in space. Cygnus X1 is around 6,000 light-years from Earth and is so dense that even light can't escape from it. That's why scientists named it a black hole. It absorbs everything, even radiation. Since then, many more black holes have been found across the universe. Some are formed when large stars collapse and are called stellar mass black holes. Others are much bigger and sit at the centers of galaxies. These are known as supermassive black holes and have the power to pull in matter from far away. The gravity around black holes is so strong that it bends space and time. This changes how stars and planets move when they come near. If something gets too close to the edge of a black hole, called the event horizon, it gets pulled in. This edge is the point of no return. Matter falling into a black hole gets stretched out into long, thin strands in a process called spaghettification. After crossing the event horizon, it disappears forever. At the center of a black hole is the singularity. This is a place where gravity becomes infinite, and current science cannot explain what happens there. The laws of physics break down inside the singularity, making it one of the most puzzling places in the universe. No one knows what truly lies beyond it. Even though black holes are dangerous, they help scientists test new ideas about space, gravity, and even quantum mechanics. They teach us about the most extreme conditions in the universe. In 2021, scientists captured the first real image of a black hole in the galaxy M87. This amazing picture proved many old theories and opened new doors to understanding black holes. Using large networks of telescopes, researchers discovered that black holes have three main parts. The first is the event horizon, where escape becomes impossible. The second is the photon sphere, where light circles the black hole in tight paths. And deep inside is the singularity, where all known rules of science fall apart. Even though black holes share these parts, each one is different in size, mass, and how it behaves. Because they're so powerful, we can't study them directly. Any spacecraft sent near a black hole would be destroyed before it could send back data. So scientists use other methods like studying X-rays and the movement of stars. NASA's research on the M87 black hole showed that its gravity can move stars across huge distances. In 1963, a scientist named Roy Kerr suggested that black holes might spin. This idea introduced the ergosphere, a zone where space itself gets twisted around the spinning black hole. Everything inside this region moves in a swirling motion. The spin can also pull in light and matter, twisting them in strange ways. Kerr's theory even suggested something more exciting, a wormhole. A wormhole could be a tunnel that connects two faraway places in space. It might allow faster travel across the universe or even access to other worlds. But wormholes are still just a theory. No one knows if they are real or if they could stay open long enough for anything to pass through. Some scientists think wormholes might collapse too quickly due to radiation or other effects. Even if they do exist, we don't know if they can be used like in science fiction. Still, the idea of wormholes pushes scientists to explore more and think about what's truly possible in space. It makes the universe feel even more mysterious. Another big theory is called string theory. It says everything is made of tiny vibrating strings that form all the particles we see in nature. String theory also talks about extra dimensions beyond the ones we know. These hidden dimensions may help explain how gravity and tiny particles work together. Some believe string theory might one day combine all the rules of physics into one big idea. That's why many scientists are excited to explore its predictions. Even though it hasn't been proven, string theory brings new connections between math and nature. It makes the universe feel like a beautiful puzzle waiting to be solved. Physicist Edward Witten once said string theory feels like 21st century science arriving early. Today, scientists use string theory to study black holes in simple space models. This may help us understand black holes in 10 or more dimensions, far beyond our daily experience. Learning about black holes isn't just about science. It changes how we see time, space, and reality. It shows us how much we still have to learn about the universe. Subscribe to our channel and thanks for watching.